because it was requested, let's go through this one. Find the value of each power of 10. 10 to the negative 3 means I need to have the decimal point 3 places from the right of the 1. I interpret this as a 1 times 10 to the negative 3, but I don't have to put the 1 there. So when we were looking at our negative powers, our rule that we came up with was it's going to be a small number, and because of the negative and the 3 means I need 2 zeros between there. So 10 to the 5, this goes the other way, that's a 1 with 5 zeros. I'll put the commas in there to help. This one, then, based on the rule on our first one, between the 0 and the 1, I need 3 zeros. Negative number is going to be small. 10 to the 0, any base to the 0 power is 1. 10 to the 7th, I need 1, 2, 3, 4, 5, 6, 7 zeros. Commas to group those in 3s, and 10 to the first power is a 1 with 1 0 after it. Write these as powers of 10. Well, this is a big number with 6 zeros, so that's 10 to the 6th. Small number, 2 zeros, so that's got to be 10 to the negative 3rd. I see the connection between 1 and 8 there. 1, 2, 3, 4, 5 zeros, so that's a 10 to the negative 6. 1, 2, 3, 4, that's a 10 to the negative 5. No zeros, that's a 10 to the negative 1. And 1, 2, 3, 4, 5, 6, 7, that would have to be a 10 to the negative 8. Okay. Values of these, this is a 10 to the 3rd power, means this decimal point needs to move 3 places. So I'll be a 502, and I need a 0 to fill in the gap there for the decimal point that I needed to move. This one, the decimal point starts here. It needs to go to the left 4 places. So 1, 2, 3, I'm going to need a leading 0 there to get it 4 places. That's 10 to the 6th. So 5, 2 here is moved 1 place, 2 places, 3 places, 4, 5, 6 places. 52.8 million, that's what that looks like. 3 places, 1, 2, 3, I'm going to need 2 zeros before I hit the 5, 4, 1 to fill in that space. The negative 2, 1, 2 more zeros there before the 0, 3. And 6 places to the left here, I've only got 2, so I'm going to need 4 zeros to fill in gaps before I have the 2, 2, 8, 1. Okay, writing in scientific notation, I want the decimal point to end up here, so it's going to make a 4.5. 4.5 is smaller than 4,500, so I'm going to have my 10 to a positive number, and that's going to go to the 3rd. This one's got to move 6 places, so that's a 6.56 times 10 to the 6th. This one I've got to move 1, 2, 3, 4, 5 places to get to the 2, so that's a 2 times 10 to the negative 5th, or if I saw it as the 4 zeros, right? And this one I've got to move 3 places to get there, so that's a 2.03 times 10 to the negative 3rd. Least to greatest on here. I could convert all these numbers, but the smallest numbers are being the ones with the most negative powers. So, and 6 is smaller than 8, so my very smallest number here is going to be the 6.18 times 10 to the negative 4, and then the 8.2 times 10 to the negative 4. That takes those two out of the list. I have a negative 3rd power here, that's my next smallest, 4.54 times 10 to the negative 3rd. I've got a negative 1 and some 2's in the power, so the negative 1 will be the next. 9 times 10 to the negative 1. And then of the squareds, the 3 is smaller than 6.5, so that's 3 times 10 to the 2nd. and this is 6.75 times 10 to the second. Okay, same thing on here. My most negative, I've got a -3 and a -3 there, but 5.4 is smaller, so 5.4 times 10 to the -3. Then the 6.6 times 10 to the -3. I've got two -1s. 2.24 is smaller than 6.2, so 2.424 times 10 to the -1. And 6.2 times 10 to the -1. Takes that out. The third powers, the 6.87 is smaller, so that's times 10 to the third. Takes care of that one. Leaves the 7.25 times 10 to the third. In 1970, the number of televisions sold in the United States was about 1.2 times 10 to the 7th. In standard form, I've got to move that decimal point 7 places. So there's 1, 2, 3, 4, 5, 6, 7. That looks like 12 million. 1950, about 3,880,000 households had televisions. In scientific notation, that is a 3.88. times 10 to the 6th. Have to move that decimal point 6 places to get it there. Volume of the cube. Volume is length times width times height. In this case, it's a cube, so they're all the same. So I need to do 4,000. Let me get this to where you can see it. 4,000 times 4,000 times 4,000, or 4 times 10 to the third times 4 times 10 to the third times 4 times 10 to the third. 4 times 4 times 4 is 64. 10 to the third times 10 to the third times 10 to the third, that's 10 to the 9th. Not proper scientific notation there. I moved the decimal point over. This is 6.4 times 10 to the 10th. This number from 64 to 6.4 got smaller, so I had to make the power bigger. One gets bigger, one gets smaller. So in scientific notation, that's 6.4 times 10 to the 10th. And in standard form, that is 64 and then 9 zeros. Excuse me. Since those come in clumps of 3 nicely like that, that should look like that.